In this unit, we're going to look at electromagnetic compatibility, or EMC. And so what this is the study of how electromagnetic energy can cause unintended effects in electronic systems, and also how we can eliminate, or at the very least mitigate, these effects. And so we're not going to take a close look at a lot of specifics because we're not necessarily equipped with the knowledge to deal with all of this electromagnetic theory. We'll get a little bit more of that next semester, but ultimately here we're just going to be taking a high-level look so that you're at least exposed to some of the big ideas in this area. So first of all, we can call these unintended effects electromagnetic interference. So oftentimes we'll call this let's clean that up a little bit, electromagnetic interference, or just EMI. And so oftentimes I'll use these abbreviations so we don't have to write out the full thing. So EMI, EMC, and then we can also have a subset of this electromagnetic interference, which is at radio frequencies. And so this is going to be called radio frequency interference. And so we can also abbreviate this as RFI. So interference. And so what we're going to see is that in order to diagnose and fix EMI issues, we're generally going to have a good understanding of a system level and how things interact with each other. So to diagnose, and ultimately what we're going to be able to do is fix EMI, we're going to need a good system level understanding. So what that means is, how are all the components meant to be interacting? How could they potentially interact in ways that aren't intended? And so there's a good example in the Stephen textbook where he talks about a robotics team that's building a robot. And so bear with me with my drawing here. You're kind of going to have to use your imagination. But basically they have some robot that's going to be moving, and it's supposed to be moving along a straight line. So what they have is they have two motors, one driving either side. So let's say we have a motor over here on the left and a motor over here on the right. And so what each of these motors have is a type of circuit that can measure the rotations of the shaft and in turn give you some type of pulse. So it can count the pulses to determine how quickly the motor is moving. So over here, this motor is also going to have a circuit. So let's just say this is our circuit, which is outputting some pulse. And so for instance, let's say maybe this motor is outputting more pulses in the same amount of time. And so what they would want to do then is they would want to increase the speed of our left motor such that both motors are going at the same speed and our robot moves in a straight line. So the issue that this design team ran into is they tested this software that can control motor speed based on the counts of the pulses coming from these two circuits. Everything looked good when they were testing it sort of on a bench top in a lab environment. They put the software then into their robot, and as soon as they tried to test it with the robot, the software wasn't working at all. And so it turns out what the issue is that as these motors are turning, they have these commutators which are connected to the coils, and the brushes of the motor are connecting and disconnecting from the commutator as the rotor is spinning around. So don't worry about that too much if none of that made sense, but the main point is that there were EMI pulses, or rather EM pulses, that were interfering with this circuit. So there were pulses coming from here, and there were pulses coming from here. And so these pulses of electromagnetic radiation were being interpreted as pulses in this pulse counting circuit, in both of these pulse counting circuits. And so what that means is that the software sees all these random pulses and then tries to correct for that to make both motors move at the same speed, and both motors just end up moving spastically. And so basically this is a good example of how you have to understand the whole system working together as a whole, because just looking at the software, just looking at a motor isolated from that pulse counting, everything would look fine. But once you put all these things together, it doesn't work as intended. So we're going to describe a little more what's going on when we have this interference here, how is that occurring in general, and then we're going to talk about some ways to fix that. So what we're going to look at in general though is a couple main categories of EMI. So main categories of our electromagnetic interference. So our first one is just going to deal with communication systems. And so of course, in general with communication systems, we are intentionally using electromagnetic radiation, but there are ways that it can sort of interfere or we can have unintended effects. And then our second sort of really broad category is just everything that's not a communication system. And so in our following videos, we're going to start by looking at communication systems. We're then going to look at other types of EMI. After we've analyzed all the different ways that electromagnetic interference can occur, we're going to come back and we're going to talk about some specific ways that we can avoid or mitigate EMI.